And there I am. So we are going to get started here. I'm just checking to make sure that we are good to go. I got to check my LinkedIn and I'm going to move us over.
All
All
right.
right, we are going live and we are live. So let me get out of studio mode. And hello everybody. And I'm not sure how many people we got out there, but I think we've got some people on Facebook already. We've got some people on YouTube. I think I saw Felix Sandoval. I don't know. Yep. So it looks like I'm live on LinkedIn. So we are live, Christy. Welcome
All
to
right.
welcome to Tech Thursdays, and we got Gustavo. Hey, excellent. Costa Rica in the house.
Nice.
Nice. Yeah,
Probably a
we
little warmer there.
and David Rodriguez. Yeah, it's a little warmer there. What's the temperature in Costa Rica, Gustavo? And we got David Rodriguez. Excellent. We got Felix Sandoval. Excellent. So people are filing in. The room is getting full. That's a good thing. And we got James Smith in the house. What up? We get so
Let me
Christy.
check.
Yeah, Christy. It's a global presence. We'll typically have people from Japan, from Costa Rica, from Colombia, not South Carolina, Colombia, and got Joe in the house. We got Giuseppe. So we'll get a good arrangement. And so let me ask you, Christy, since you're
Hmm.
talking SCCR,
Yes, I am.
does does it matter what country you're in for an SCCR rating?
Yeah, a little bit.
A little bit?
It's always important. So, but
Okay.
there are some different terms that are used in different countries. So there's a
Uh,
Europe, particularly European standards, IEC standards. It's not a one-to-one comparison because they literally just call some things something different. So when you're looking up information about SCCR on something, it can be really difficult to find it because you might be searching for SCCR and they might call it something else.
okay.
Uh, so
Yep.
that is, and it might be essentially the same thing, but it's a different term. So it can make it hard to navigate when you are trying to compare them. But the concept is important everywhere. But the
Absolutely.
terminology and the actual ratings may vary depending on
Absolutely.
where you are.
Cool beans. Okay, so now that we've getting some people to dial in, and even if they come in, they'll and Felix Sandoval out there, and we've got Robert from Omaha. So, Christy, why don't you tell us a little bit about you, who you are, your background, and all that jazz, and a little bit about your time with Eaton and jazz.
Sure. So my name is Christy McElhinny. I am currently the field application engineer for the Busman division. My territory is a very weird shape. I have all of New England. I have all of New York State except New York City and Long Island. And then I have Western PA, West Virginia, and Kentucky, and Puerto Rico. So
Oh,
that is I have
you've
Puerto
got
Rico now.
Puerto Rico.
Yes.
I didn't know you had Puerto Rico. That's
I
pretty
just
cool.
I just got it this year and I haven't been able to travel there yet, but I am very excited to be able to get to go there.
Excellent. And we got New
Yeah,
York State in the house. Do you have New York, right?
I do. I have, as long as you're not on Long Island or New York City, I have New York. I used to have those, but it's nice to see Busman actually added more field application engineers, and then all of our territories got a little smaller, which is good. It hopefully means we'll be able to get there. But I used to have from basically Virginia north.
Right.
And now we have an application engineer who kind of takes the coast while I take that northern half. So it's
Perfect.
a good thing. We've got a lot more. We added, I think, three new application engineers just this year.
Well, that's
Um,
cool. That's
very
pretty
good.
cool.
Very good
Yeah.
for all of us.
That's really good. So what did you do before Busman? Did you say
Before
that
Bus
already?
I did not. So before I was with Busman, I was still with Eaton. And I joined the company right out of college, and was in their technical sales leadership development program. So which basically they take you for a year and they train you on how to do that technical sales job. And then I was for 5 years, I did like industrial control and automation sales for Eaton in Western Pennsylvania.
Oh, that's cool.
Um, Before, and now I'll be with Busman for 4 years this summer.
Wow.
So it's how long I've had this current job, which is wild. I can't believe that.
Yeah. Well, your industrial controls background lines up very well, not only with fuses, because we use a lot of fuses inside of industrial control panels and things like that, but also with this topic, short circuit current ratings. So you were probably dealing with short circuit current ratings and working with customers even before you were with the Busman Group.
Yeah, it was always very important in that, and especially when code changes started coming out, and you saw it more and more important. And so I started actually teaching short circuit current ratings as as an OEM salesperson in Western PA, and that's what kind of got me the position I have now. When this position was open, I was like, that's my favorite part about my job in industrial and automation controls.
Yeah.
Can I do that and only that now? Well, it's not like it's only that, but do more of that. And yeah, so that it was a great way to learn it, and it also gives me a broader perspective. I think it's obviously the fuses for Busman, but I have sold every other component in the panel too, which really helps.
Oh yeah. Yeah, yeah, yeah. And like you say, there's terminal blocks, there's relays, there's all kinds of
Hmm.
stuff inside of control panels. So well, that's pretty cool. So you are going to hit SCCR. And when I say you are going to hit SCCR, that's what I mean. So I'm going to be, this is like usually on Thursdays, I'm like doing everything, right? So now you are, I'm supporting your effort.
Love
So,
it.
and Robert from Omaha says that he did 8 weeks hurricane disaster relief work and electrical safety in Guayama and Ponce, Puerto Rico.
Wow.
Excellent. Wow. That's pretty cool. That's pretty cool. And then he brought up 50 hertz versus 60 hertz. That's another distinguishing factor. But a lot of the overcurrent protective devices are rated for 50 and 60 hertz.
Sure.
It's when you start getting into like airline and like 400 hertz and things like that that everything starts to change.
Hmm.
All right. So we have your slide deck.
Yep.
Your contact information is out there for everybody, right? So everybody knows who you are now.
That's okay. Please feel free. There's a lot of things in here. I tried to keep this as general. It's specific in a lot of ways, but there's still so much more about SCCR above and beyond what I'm planning to talk about today. So if you are in one of those situations where you need more information, please do not hesitate to reach out to me, especially if you're in that territory. But if you're not, I'll probably still help you, or at the very least direct you to the right person. So I
Perfect.
am more than happy. I love SCCR, I was telling Tom before, is kind of my favorite topic that I cover. It is different every single time. It's like a puzzle every time, right? There's a couple
Hmm.
pieces, and you try and make them all fit together so they work right. And I'm a big fan of that. So definitely feel free to reach out to me.
Excellent. And as you dig into this topic,
Hmm.
I'll try to ask questions every now and then, but I'm going to watch the chat and for any questions though. So I encourage everybody out there, please use the chat, ask questions. So I mean, she's a walking dictionary when it comes to SCCR, and I know we're going to have a good program. So all right, Christy, I'm going to let you take it away.
Okay. All right. Well, then our agenda, if we go to that, is first and foremost, what we have to talk about is fault current. And you'll see why. And it's basically that is what we are always going to be designing our equipment SCCR to. I want to touch on interrupting rating as well. And I want to touch on that because a lot of times interrupting rating and SCCR get confused. They're sort of related, but they're not exactly the same thing. So I want to make sure we understand interrupting rating, and then we'll talk about equipment SCCR. And in equipment SCCR, we'll talk about the NEC requirements about it, and then we'll talk a little bit about how we actually get the SCCR rating that we put on all different sorts of electrical equipment that's out there. That what people are usually reaching out to me for is methods to fix inadequate equipment SCCR, right? It's all too common that it comes out that we've installed a piece of equipment and its short circuit current rating is lower than the available fault current. Now what do we do? So we'll talk about some sort of engineering methods we can use for that, and then we will talk a little bit about series ratings too, because that's actually usually sort of the NEC requirements for series ratings when we can and cannot use fuses to help us with an inadequate short circuit current rating. So with that, we will just dive right into fault current. In the 2020 NEC, we finally got a definition for fault current. Can you believe that it took until the 2020 NEC before we got a definition? But we did. So the fault current is defined as the current delivered at a point on the system during a short circuit. So that's my fault current. I have a short circuit, however much current is there, that's my fault current. The available fault current, which is something else that we got a new definition for in 2020, is the largest amount of current that is capable of being delivered during a short circuit condition. So again, that could be any type of short circuit. It could be a ground fault. It could be a line to line. But the available fault current is going to be a three-phase fault. If I have a three-phase system, it's going to be the line to line to line fault will be the available fault current. That's going to be the greatest amount of current we can see. And the really big thing here, just with this term, is you'll see a lot of. I have a lot of code coming up in this presentation, and you'll see available fault current in blue italics a lot, and that's because we finally got this term, and we propagated it throughout the code, whereas there used to be a bunch of different words we would use for this. We used to say short circuit current. We used to say maximum short circuit current,
Hmm.
maximum available short circuit. So it's just a nightmare when it comes to actual consistency of what we used to call it in the NEC. And now everywhere it's available fault current. So it's kind of nice. And we have this nice little diagram. They added this informational note to the NEC as well. And what you can see is we've got a source. Right at the source, we have an available fault current. And then you can see we've got some sort of conductor, right? And there's going to be impedance in that conductor. So when that conductor, right, coming into the incoming terminals of my next piece of equipment, it's going to have a different available fault current right there, right, to account for that impedance in that conductor. And then we've got right that equipment right there. That equipment will have a short circuit current rating. It's going to have other devices inside of it, probably an overcurrent protector device with an interrupting rating. And then downstream from that to my next load, right? And that could be my final load, or it could be another piece of electrical equipment, right? It could just be a feeder going somewhere else. I'll have another available fault current because, again, more impedance in between.
You see, Vinny Petroni is online, and
Yep,
and Vinny said, "Fuse it or lose it." So,
love it.
so I got my hat out. Fuse it or lose it. So I can
It
always
was
wear my
very.
hat when we do this presentation.
See, I need one of those. How do I not have one of those
You know
hats?
who you know who I got this off of? Jim Dollard gave me this one. He had it. I think Tim Serco has one, Vince Saporita has one. This is a collectible right here.
Yeah,
We got to make some hats. Got to make some
I
hats.
agree. All right, so interrupting rating, SCCR, not the same thing as interrupting rating, right? So interrupting rating is it's a lot like what it sounds like, but it applies to overcurrent protective devices. When we say overcurrent protective device, we're typically talking about a fuse or a breaker, although sometimes in an industrial control panel, it can be something like a manual motor protector. But the interrupting rating, right? The overcurrent protective device, that's the device that is active during a short, right? It's what's physically going to open the circuit. The breaker's going to trip, the fuse is going to open. The interrupting rating is the most amount of current that it's rated to safely interrupt, right? So what is that current that it can interrupt. There's an NEC requirement, right, about interrupting ratings. 110.9 is essentially going to say all my interrupting ratings should be greater than or equal to the available fault current. That makes sense. It's just like something like a voltage rating, right? You want your voltage rating to be greater than or equal to the voltage of your system. You want your interrupting rating to be greater than or equal to the available fault current. Another very important thing to know about interrupting rating is that it is a self protection rating only. So, right, if I'm a breaker and I have a 35,000 amp interrupting ratings, it means me, the breaker, if I see 35,000 amps, I will trip, I will open the circuit, and I will be okay at the end of it all. But I'm not guaranteeing the protection of anybody around me, right? That's actually when we get into SCCR. SCCR has to do with the entire assembly. Interrupting rating is just a rating for that breaker or for that fuse.
And I
Um,
think too, Christy, Robert from Omaha brought it up about 50, 60 hertz, right? In the interrupting ratings, I know that there are resources to derate the
mhm,
interrupting capabilities. When you go to those very high frequencies, if you look at the overcurrent protected devices, they'll have a 50, 60 hertz interrupting rating. But when you start getting outside of that, you really need to consult the manufacturer to say, okay, what is my new rating, right?
mhm.
So that's another aspect, and he brought something else up as well. He says, "What about ambient temperature impact of this?" And I like the way you described this, and I'm going to steal it from you. That interrupting rating is about the device itself. It's not
Right.
about anything around it, right? So when you
Nope.
think about this device, you really have to understand what its capabilities are and what it's based upon the environment that it's in, whether frequency and all that good stuff play a role. When it comes to ambient temperatures, I think ambient temperatures are more critical, and you might have your opinion on this too. I think ambient temperatures are more critical when it comes to overloads and things like that,
I
more so
completely
than the
agree.
short circuit, because the magnetic forces of fault current is what drives that device to open, whether it's a breaker or a fuse, right? Uh,
Correct.
Not necessarily. Now, in the overload region, I know on breakers, they'll have ambience on the trip curves because in some cases, my bimetal inside of that breaker may be moving. I don't know as much of the impact on a fuse as I don't think it's as significant on a fuse as it is on a breaker.
Yeah, there is ambient changes, and again, it is usually to that overload region because that's where it's the most sensitive. High speed fuses are more sensitive than
Hmm.
a normal UL low voltage fuse, and medium voltage fuses can be a little more sensitive as well to it. But yeah, they exist. There are D ratings if you're in a higher temperature, and that makes, I mean, that fuse is just all based on a thermal principle. So if the inside of it's going to melt at a specific temperature associated with a specific overcurrent over a specific amount of time, and it starts out as at a hotter temperature, then that is obviously going to change when it melts. Although I do think there's sort of a larger amount of temperature where you don't have to derate until you do with a typical low voltage
Gotcha.
UL fuse. Yep.
Now, David Rodriguez brings up a good point. It's a pet peeve of mine. I am not very. I am not very. I don't like the term AIC rating because AIC is amp interrupting current rating. And
Mhm.
when you to your point, interrupting rating is around the overcurrent device. It's not around everything else that's around it, right?
Yep.
So it's it is important to understand that, and when you see something that has an AIC rating, yes, the short circuit current rating may be based upon the highest interrupting rating device or the lowest interrupting rating device that's in that
Yep.
piece of equipment, but it's not an AIC rating, it's an SCCR rating.
Correct. Yes, the entire yeah, the when you see AIC actually should only apply to something with an interrupting rating
Yeah,
because it actually has to do with that I is interrupting. And the only thing that's doing anything during it is the overcurrent protective device. Everything else, think of everything else in a panel. A bus, you think about a terminal block. what are they doing during a short circuit? They're sitting there and they're waiting for a breaker or a fuse to open. So they're
Right.
not interrupting anything themselves. They are just, I mean, we used to use the terminology withstand rating more, and that's almost, I mean, they moved away from that for other reasons, but that's more about what it is. It's trying to
Yeah.
withstand however much current it's going to see until an overcurrent protector device opens and protects it.
And you know what? I love the term withstand. That's
Hmm.
in my opinion, I like that better than short circuit current rating because I think people get it better because interruption is
Hmm.
stopping the flow of current and withstand is being able to withstand the current passing through you, the forces and all that good stuff. So and now Vinny brings up, what about when I first read it, I thought he said, "What about attitude?" And I'm like, "We're all full of attitude," but he's talking altitude, ski resorts. I mean, I don't know. Altitude plays a role. I mean, the air gets thinner up there, right?
Yeah, I think it's one of those. There are derating charts for altitude. I don't know at the point at which it starts to matter, but there are altitude adjustments for some equipment out there. So, yeah, if you're at a particularly high altitude, that is certainly something that you would want to make sure there's a derating for.
Yeah, absolutely. And it's understanding the application and understanding the ratings.
Hmm.
Cool. And then, I mean, we haven't even got off of, Sharice brought up SCCR versus AIC, and that's two different things, and which is, I think that's what you're going through right now. This is interrupting current.
Exactly.
And
Hmm.
we'll get to the enclosure and the ratings. We'll get to at 110.10 is more that's your withstand rating.
Yeah, we'll get to 110.10 very
That's
shortly.
right. We can't even get off the second slide.
Yeah, we're just getting in order here. Oh, here we go. Everybody's favorite part of any busman presentation, right, is an example of when we don't have enough of a specific rating. So this is an example of not enough interrupting rating, right? That's just to demonstrate why it's so important. So 480 volt system. This is a 15 amp. You can see it's a 2-pole molded case circuit breaker. We shorted it right there on the load side terminals. 14 kA interrupting rating. 45,000 available fault current, and go ahead, play that video. Let's see what happens to
Here
this
we
gal.
go.
This is also in slow motion. Believe it or not.
I got to turn up my volume when it first happened, so I had my volume down.
Mm,
That's okay though.
yep. This is my favorite. This is my favorite part. This last final piece. It's just like the Death Star exploding in slow motion.
The Death
It's
Star.
yeah,
I love it.
it's kind of like that.
You know
So
what?
this is
Dan
oh,
Neeser calls that an unintended rapid disassembly in the field.
mhm, yes. I call it the Death Star exploding.
I like yours better than his.
Yeah. So, long story short, this is a violation of 110.9, and not something one. If you want to go to the next slide, we can actually see it.
And
The
OSHA
little
1910-303B4.
there's a lot of violations in this single video. So, we might say this did interrupt the current technically, right? It interrupted.
Sure.
There's no power flowing through there anymore, but this is not a safe interruption of the current. Very important distinction. So these still frames I think are fascinating because you can actually see this breaker knows that it's seeing too much current and it's trying to open. And it's trying to open, and when it's doing that, it forms an arc between its contacts and it tries to extinguish that through its arc extinguishing through the arc shoots, but there's just too much. There's just too much energy for it to be able to handle, and we get the rapid disassembly in the field, whatever it was
You
called.
get the kaboom.
You get a kaboom, exactly. So I think we have another example here of it's same thing with the fuse, right? We got to be fair. We got to do it to a fuse as well. This
Mhm.
is a 60 amp class K5 fuse. So this is a much older style fuse that only has a 10 Ka interrupting rating, not that high interrupting rating we typically associate with fuses. It's the
Would
lower one
this
that's 10 Ka.
would this be
Yep.
like the NON fuse now?
Yeah, similar to that exactly.
Okay.
So 480, we did the same thing. We shorted across the load side. Go ahead and play the video. So more or less the same result here.
Yeah.
A
I-
little bit less debris. You just don't have the molded case frame to fly all over the place. But this is also, you'll see violation of 110.9 and OSHA. In the little still frames on the next slide, you can see that hot spot that just turns into a big old kaboom here. So it knows there's too much current, it melts, but there's too much arc, it's too much energy in that arc, it's not able to extinguish it safely. So then of course, the most boring video you can ever watch is the proper application of a non-indicating fuse. So we have the exact same fault, again, exact same setup, voltage, available fault current. We've shorted it across the line side, but now we have a 60 amp class J fuse that has a 300,000 amp interrupting rating. And what you'll hear, there's a beep. When the beep occurs, that's the fault. So you can play it.
There we go.
And that's it, right? So certainly a lot more boring of a video for us to watch. But if I'm standing in front of any of these three pieces of equipment during a short circuit, I would prefer it to be this one, right? We want boring in our actual equipment.
Yeah.
So
And when you hold that fuse after that, it is kind of warm.
yeah, kind of it's definitely warm.
It
It's
is.
not kind of warm. It is hot.
Yep.
That's just about the only indication you're gonna get. So that covers interrupting rating for us. And now we will talk about short circuit current rating and hopefully distinguish really how they are different. Short circuit current rating, by definition, is the prospective fault current that a piece of equipment, right, an apparatus, or it can be connected to. So how much it can see without sustaining damage exceeding acceptable criteria, that's just my favorite part of the definition, right? What is an acceptable amount of damage? What isn't? And who gets to decide? So it's how much it can be connected to without, sustaining too much damage. When I don't have sufficient SCCR, I'm going to create one of or more of these three hazards, being a shock, fire, or projectile hazard. So the shock hazard is typically a result of conductors pulling away from their terminations. So if the conductors pull away from your terminations, you got just like live wires flying all over the place. That's not good. That's a shock hazard. And they could also possibly energize the enclosure, another shock hazard. A fire hazard, that's right, explosive power blowing off the door, exposing the flames to others. And the thing about a fire hazard that can be interesting is depending on this particular UL standard you are trying to meet, you can create a fire hazard, but as long as the door doesn't blow open and expose you to it, you've passed the fire part of the SCCR test. So that's why sometimes you see specific pieces of equipment that have really beefed up hinges and doors, and that's so that the door doesn't fly open during it. You can create the fire inside, and if the door doesn't blow open, you haven't created a fire hazard. I always like to stress at this point that SCCR, the short circuit current rating of equipment, does not mean that that piece of equipment will be able to immediately be able to be used again, right? It does not mean that it's no damage to it at all, right? It just means no damage exceeding a certain amount. So if I can create a small fire inside of it, and as long as the door doesn't blow up and I'm okay, then obviously I'm not going to be able to use that piece of equipment again immediately. There's going to have to be some changes made. So it's a different type of protection. If you want to be able to use it again after a short circuit, it's something called type 2 protection. Not the same thing as short circuit current rating. It's an extra level of protection on top of that. And then the final one, projectile hazard, that's usually pretty obvious, right? Shrapnel, pieces of debris flying all over. So if I don't have enough SCCR, I will create one or more of those hazards. But the big thing, again, is this is going to apply generally to your entire assembly. So whatever inside your probably gray box, that whole assembly will have a short circuit current rating.
And I think, yeah, that's and when you were talking about damage, I
Mhm.
in 110.10 it says To permit the circuit protected devices used to clear a fault to do so without extensive damage to the electrical equipment of the circuit. So it doesn't mean that it won't, to your point, it doesn't mean it's not going to have any damage. It could have damage. It may not be
Yes.
able to be placed back into service. It's just not going to create a shock hazard. It's not going to create that additional hazards and arc flash and all this other good stuff.
Yeah, I mean, I've had the number of times people have called me up and say, "Hey, what something happened. I had a short circuit inside my piece of equipment, and this, thing burned up, and I can't use it again. Was the short circuit current rating wrong?" And it's not necessarily.
That's right.
That might be exactly what it's below the threshold of hazard. It's deemed the acceptable damage, I guess,
Yeah.
whenever you have a short circuit. It clears the fault, hopefully, safely. But you might have to do some equipment modification.
Good discussion.
So here, once again, a misapplication of short circuit current rating. So this is a combination motor starter. This is at 480 volts as well. 5 kA SCCR, 50 kA available. Play that video.
3, 2, 1, 0.
I love the uh-oh at the end. Like, that's just like the perfect amount of concern, right? So again, if you go to the next one here, we can see these still frames of this, and you can see right at 0.01 seconds, this is done for, right? Gone. No more. And this makes sense when you think about it, because the worst part of a short circuit is going to be the first peak, because in the real world, we tend to have asymmetrical short circuits. That means that the very first peak is going to be the tallest. So the first half cycle, which is the first 8 milliseconds, give or take. So you're going to know immediately whether or not your equipment has passed or failed, right? You'll know within 8 milliseconds, because that's the most amount of energy it's going to see. So here at 0.01 second, we're done, right? We have not, there's certainly a fire and a projectile hazard here. We can't quite tell if any we've created a shock hazard, but we've at least failed 2 out of 3 of our criteria on here, and likely 3, but at least 2.
Now, David Rodriguez had a question about how do you know to replace the fuse? Like you said, when it opens, a circuit breaker, you're going to see the handle in the off position or in the center position. What about a fuse? What happens?
Well, if it's a non-indicating fuse, nothing much happens, except you should notice that you've lost power somewhere else. So that's usually your
Yeah.
biggest indication. There are accessories and or indicating fuses that exist. So you can get a fuse that will it will change a color on it. It'll go, I believe, from white to black on most of the Busman ones, and tell you that it has opened. So as soon as you open the panel, you'll be able to tell. Some holders or switches that the fuses go into have little LEDs that'll alert you too that, hey, this is the one that's open for you. And you can always check the continuity between the two. That's the old school way, right? Just take a check each side and see if you can get power through it.
Yeah.
That's the easiest way, if you have none of those other methods of indication, to tell which fuse has opened.
Cool. And then if it interrupts below or close to the interrupting rating, can it be reset and used after one time? And I'm sure he's not talking about the fuse itself.
Yeah. If
But
you can find a way to reset a fuse, let me know.
yeah. And I would say that if you're below the interrupting rating of the fuse, you're up around 200,000 amps, right? And to our earlier discussion, that 110.10 says that you can still have damage to the equipment. If you have a fault that's close to the interrupting rating of a fuse, I would say you're going to be looking at that equipment overall and doing some further analysis before you do anything. Before you put it back into service. Now, he says even a breaker. So let's talk, Robert. Let's talk about a circuit breaker. If you have a piece of equipment that's being protected by a circuit breaker and you're up near its interrupting rating, then the equipment itself, I mean, you're going to let through even more energy from the circuit breaker just because of the clearing time in the instantaneous region. You're going to have a 0.02 seconds, right? So you always will be looking at the available fault current, and Vinny pointed it out that peak current will be different because, and I think you have pictures of the waveforms, what current limitation is, and what Vinny is talking about. You'll be telling everybody that information with regard to that. So I would say when you have a fault inside of a piece of equipment that was high enough to open that breaker or fuse, an evaluation of that equipment after you figure what the fault was, because 70E tells you need to do an evaluation and an analysis. So before you do anything with that device. So and Sharish, we are if Christy is going to be covering how to address the SCCR inside of a panel. So good questions.
Hey, look, we finally got to 110.10. So 110.10 is really the sort of overarching requirement for SCCR. Now, SCCR is not actually mentioned in 110.10,
Right.
but what it's telling you is that everything, all of your overcurrent protective devices, it does say short circuit current rating, right? It should all line up so that you don't get extensive damage to your system. And if you're going to have a short circuit current rating that causes not extensive damage, that's basically telling you your short circuit current rating's got to be greater than or equal to the available fault current, right? That's how we achieve that. Now, this is going basically in through, hey, when you do your fault calculations, you get to count impedance of conductors and all of that too, which is great. But that takes into consideration the available fault current at your piece of equipment. So again, SCCR, greater than the available fault current. And again, the SCCR, that applies to your whole equipment, right? Your overcurrent, your breaker inside of it, your fuse inside of it has an interrupting rating. The SCCR, right? I think a lot of times they get confused because they're both in KA, but SCCR is for the entire piece of equipment as an assembly, and the interrupting rating is just that breaker or just that fuse. So we'll talk a little bit here about what the NEC has some marking requirements for SCCR, and I've included basically just because in 2017 there were a ton of changes or additions made to short circuit current rating in the NEC. So I want to make sure we review what those were, as well as give you a couple of the updates that also occurred in 2020. You'll see it basically just gets more and more important. The NEC is clearly telling us that this is something that we have to pay attention to. So here in this right here are all of the different types of equipment per the NEC that are required to have the short circuit current rating listed on it. Now, most of these, this is like not even news because the UL rating for all of these pieces of equipment, the nameplate you have to put on them for those would tell you that the short circuit current rating has to be on there, but NEC added it, and you'll see transfer switches are a little bit different than everything else, and we'll talk about them specifically in this presentation as well. So yeah, they made some additions saying it has to be marked on there, but what's really different is the requirements to know and document your available fault current. So if you go to the next slide, Tom, you'll see here's all the different types of equipment now that have some sort of requirement for you to know what the available fault current is. And so it might be documentation, so just proof that you've done the calculation and you know what the available fault current is, or it might actually be a marking requirement, so a field marking. You got to actually put a sticker on your piece of equipment that says the available fault current here is X. So you can see all of those different types of equipment, and we'll go through each of these individually, so I'm not going to read them out now. But it's very, very clear from this, right? And from 2017 to 2020, this is important, something that's been added. So.
And the 2023 is not taking anything back. They're even looking at expanding those marking requirements. So
I can only imagine.
Yep.
So the first thing we'll talk about is service entrance equipment. So this is really the first one that ever got a requirement for available fault current. In 2011, NEC, they added a requirement that the available fault current should be field marked on the equipment. Now, they probably didn't use the term available fault current because only this year is it a consistent use of that term. So you'll see in a lot of these, the blue italic 2020 changes are going to be just the word available fault current. But yeah, you had a field mark. In 2017, they added an additional requirement of documentation. So it's not just field marking it. It is also making a document available to anyone who is going to maintain it. A lot of these requirements for available fault current and from a simple enforcement of the code, right? You want to make sure your short circuit current ratings are greater than the available fault current, but available fault current, not like voltage, where it's not particularly easy to just know what the right? You voltmeter on it and you know what the voltage of your system is. Available fault current is a little more complicated than so you can't, in order to know that your ratings are adequate for the available fault current and enforce that they're not being installed somewhere that they shouldn't be, you have to know what the available fault current is. So all of these changes aren't necessarily changes in, hey, SCCR is important and it should be greater than the available fault current. It's so important. We know you might not know what the available fault current is, but you have to now, and you have to verify that the equipment being installed has adequate ratings to that available fault current.
Yeah, Christy, and I'll give you some insight on why they required that documentation. I know Donnie Cook and a few other electrical inspectors would show up on a job site and they would see, here is the available fault current at this panel, and they would have a very short run of conductor, and there would be like say you said there's 60,000 amps at this panel, and there's 10 foot of conductor, and they said there's only 8,000 amps at this panel, and they would go, something doesn't smell right, and then they would take that FC squared app and run a short calculation, and then go back to the contractor and say, look, I believe that number, but I don't believe this number. So they were getting so much of that the public input said, hey, you know what? We want that documentation so that they can at least look through and say, okay, what's the length of the conductor, and make sure that they feel comfortable with how they arrived at those numbers.
Yeah, smart.
Joe Bellantoni in the house.
Oh, hey there.
You know Joe?
Yeah.
Yeah.
He's in my territory.
Yep, he sure is.
So the next update, right? So this was a 2020 update, was Article 408, and that's for switchboard, switchgear, and panel boards. So now they also need to have a short circuit current rating not less than the available fault current, right? So that is there's some exceptions in there. So 1 and 2 family dwelling units, you don't need to have that available fault calculation done, but everything else, it should have it. So that's a new addition. You go to the next thing, I just want to highlight. So this is an example. This is sort of the easy version of a short circuit current rating and available fault current, right? This is a fusible panel board. It is listed with a short circuit current rating on it. And then you have the label right below it of showing you what the available fault current is, the date the calculation was performed, everything that should be on there per the NEC. So this is sort of the easy version, ideal version. If you go to the next slide, you'll see it actually can get a lot trickier if you have a breaker panel board or switchboard. And that's because you look at a breaker panel board or switchboard, and the SCCR is probably not actually marked on the nameplate. Instead, you get this paragraph. And this paragraph says the short circuit current rating of the chassis is equal to the lowest current interrupting rating of any device installed. So the reason that they do this is because that once a piece of equipment like a panel board or a switchboard is installed, there's a lot of modifications that can happen to it in the field. Maybe you take out a breaker and you replace it with a different one. Maybe you had some provisions and spares in there and you just add a new breaker. And if you had a panel board and it was rated 65 kA and then you add an 18 kA rated breaker to it, you don't have a 65 kA rated panel board anymore. You have an 18 kA rated one. So it's equal to the lowest interrupting rating. And it can be a pain for inspectors to actually figure this out, because sometimes it's that information is hidden by a cover. You have to actually take off some of the dead fronts in order to actually identify it. But you don't have an SCCR written on your panel board because it is just equal to the lowest interrupting rating.
And in some cases, the interrupting rating is not visible from the
Hmm.
front. You've got to take the breaker out and look on the side, like especially the miniature ones. So I had an idea for a public input, which I think I made it or somebody made it, and I'm not sure what they did with it. Um, for this cycle to say, look, we should mark a panel board short circuit current rating on it. And a lot of times when I say we should mark it, they'll say, well, Tom, it's already required to have that and it's part of the listing. But to your point, Christy, it's I call it a recipe, not a rating, because it tells you how to determine it. It doesn't tell you what it actually is.
Hmm. Yeah, it's not written on the panel board label. It's not actually required. Like this counts as a short circuit current rating, and I
Right.
agree that precisely it's a recipe. So you do have to be able to figure out what that. I would love for it to get. We'll go into what transfer switches get, and it would make a lot of sense for us to have a requirement the way that transfer switches do for SCCR. But it's just a little teaser for for when we get to transfer
There you
switches.
go.
So yeah, and then panel boards can also be tricky because they can be series rated. We'll go into series ratings later, provided that we still have time. But so it can get really complicated with the series with the ratings for those. Industrial control panels in Article 409. So you got the SCCR marked on there. That's not new. Determine the available fault current and provide documentation. So that was something right added in 2017. That if that I think I have an error through here. So the red is 2017, the blue is 2020.
Correct.
Basically, because the only thing you'll see changed with blue is available fault current. You'll see literally just the phrasing they find is where they made it available fault current consistent throughout the whole code. So don't install these. So industrial control panels, don't install where the SCCR is listing the available fault current. Now you got to know what it is. The same requirement. I mean, a lot of these are the same. I'm going to kind of fly through these because it's pretty repetitive. Motor
Yeah.
control centers, same thing. Marked with the short circuit current rating, document the available fault current. HVAC equipment, same, determine that available fault current. Now this one is the one that I get the most phone calls about, probably of
Hmm.
all of them. And a lot of it is, so there used to be exceptions to that SCCR marked on the nameplate. It used to be that if it were 60 amp or less, you didn't have to have an SCCR. Now the only exceptions that remain are if it's single or two family home or if it's cord and plug. Everything else has to have an SCCR. And generally, they're pretty low. That's why we see a lot of problems with these. Got to determine that available fault current and then don't install where the SCCR is less than the available fault current. I have a theory that the reason I get the most calls on this is because the people who are specifying and purchasing HVAC equipment are typically not the electrical engineer or the electrical contractor. Right. So it's the mechanical engineers and it's the HVAC contractor who are buying these, and they may or may not know what SCCR is. Right. So it's really, really important that somebody, before the inspector is looking at it, right? The inspector looks at this. He catches a lot of them because this is one of those things that happened I was added to the 2017 NEC, and it was like known to inspectors as a gotcha. So they were looking for it. So a lot of them caught it. Um, and a lot of the ratings are pretty low because nobody paid attention to this before. And lower rated equipment is cheaper equipment. So if you're trying to win the bid, you bid the lowest one and nobody paid attention to it. Well, now people are paying attention to, and it's starting to cause some problems. So we'll look again at this one later in the
Okay.
presentation to say, what do
Yeah.
we do? So we will cover this because that is, I get in 2017, I got a phone call a week about this
Yeah. So,
easily.
and Shreesh was asking about, do terminal blocks affect the short circuit current rating? And I believe you're going to get into that, but they could, they definitely can. And then Vinny pointed out that contactors and other components similar to contactors could have an integrity issue after the fault due to the stresses on all those. Think about those contactors that are in there, but terminal blocks definitely listed with upstream overcurrent protected devices, and I know you're going to get into all of that.
Yes, I will. Elevator control panels, same. I mean, this is just repetitive here, but field marked with the available fault current, don't install where it's less than the available.
The issue that I get more phone calls on this one because
Hmm.
the elevator manufacturers don't make anything greater than 10K.
Yeah.
So, and I know there's one manufacturer of an elevator control panels that basically says, here, you need to install this transformer in front of this equipment to knock the fault currents down. And that's a lot of, I mean, that's, you need space, you need more overcurrent protective devices. And you don't, I just wish that they would raise the SCCR because it can be very simple to do.
It can be, yeah. And then last but not least, for industrial machinery in Article 670, SCCR marked on the nameplate, field mark again with the available fault current here. Don't install where the SCCR is less than the available fault current. So just another piece of equipment that this applies to. And this one is a little bit different than the rest. This has to do with transfer equipment. So this is transfer equipment, think an automatic or a manual transfer switch. It is in 4 different sections of the code because it's in emergency systems legally required to stamp any of those systems that might have a transfer switch. So it's in multiple sections, but it's all the same thing. So I'm only going to show that to you once. But this is actually an example where the SCCR is field marked. And you might say, wait, that doesn't make any sense, right? Doesn't the manufacturer tell me what the short circuit current rating of this is? And the answer is yes, they do. And this is how they do it. If you go to the next slide, right, they give you a giant label, a giant label that has about 9 different possible short circuit current ratings on it, depending on what you put upstream. So there's an SCCR based on having a specific breaker. So this is an Eaton transfer switch, and they say, okay, here's an Eaton transfer switch. If you have these specific Eaton breakers in front of it, it'll have this SCCR. And it'll also have different ones at different voltages. And then they'll have it, if you use anybody's breaker, and it opens in this amount of time, in 3 cycles versus 30 cycles or anything in between, it might have this different SCCR. And then there's another one, if you go to the next slide, for if there's a fuse in front of it. All right. So depending on whether, so this is the label that tells you what the short circuit current rating is. And inspectors were saying, I don't want to have to, because of whatever's feeding it may not be in the same room, right? So
Right.
this is saying whoever installs it, you got to look at this label and you got to tell me what the short circuit current rating is, and you just have to mark it on the outside. So it's, you fill it in, right, in Sharpie or something a little bit more permanent than a Sharpie on the outside of it, and you actually field mark the SCCR based on what is installed as the overcurrent protection in front of you. Something kind of weird that can happen with an ATS, right? An ATS can have 2 separate feeds, right? You can have one
right.
from normal, you can have one from alternate. If it's not the same device, you might have 2 different short circuit current ratings. And if that's okay, because you're going to have 2 different available fault currents. You're going to have an available fault current from normal and alternate. So you want to just make sure that those all match up. But you may have 2 different, might have 2 short circuit current readings, one from the normal, one from the alternate. So just a little bit of uniqueness to a transfer switch.
So Robert says duct tape and black magic markers for labeling. That's okay?
Yeah, well, you check with your AHJ. I'll leave that one to the AHJ.
Yeah. That's living dangerously.
Yeah. It is probably not, but check with your AHJ. All right, so now we'll actually talk about how we determine equipment SCCR. So there's 2 main ways that we do this. And if you go to the next slide, you'll see the most common one is probably short circuit testing, right, in a high power laboratory. So you build a piece of equipment, you ship it to UL, they zap it with a ton of current. If it doesn't create a shock fire projectile hazard, congratulations, you have a short circuit current rating for your piece of equipment. So obviously it's a little bit more complicated than that. It's to a specific product standard, but more or less that's how it works. And if you're building the same thing over and over again, this makes perfect sense, right? Because you just have to get it tested once, and you can, to get it tested once, and you have a rating that you can use over and over and over again. For pieces of equipment that tend to be a little bit more custom, such as control panels, we have an analysis method, right? So an analysis method, and the one we're going to talk about is UL 508A, Supplement SB details a way that you can determine a short circuit current rating or an industrial control panel without having to do the short circuit testing, right? So you don't actually have to test it. You can figure it out based on what's inside. So go to the next one, you'll see that whenever we do this, your panel SCCR is going to be based on the ratings of your internal components. And it is going to be based on the ratings of those in your power circuit. I do always like to emphasize that. So in an industrial control panel, we typically have both power and control. Power we define as anything that goes to a load, right? So if it goes to a load, we call that part of the power circuit. If it's just electrical signals, right, that's control. It's inputs, outputs, turn this on, turn this off, close this contactor. That is control. And anything in the control circuit, we ignore when it comes to short circuit current rating. So it's all of the power circuit components, those that feed loads. And they're going to have two ratings that we care about when we try to determine the short circuit current rating of a panel. It's going to be SCCR ratings or interrupting ratings. Now, we should already know the difference between these, but a refresher, right? Interrupting ratings applies to my fuse, to my breaker, sometimes something like a manual motor protector inside an industrial control panel. That's the device that's interrupting the current. And it's really important to note that the interrupting rating, right, by definition, the interrupting rating is the maximum amount of current that something can safely interrupt. So that's never going to change depending on what's upstream from it, right? If I am a breaker and I can safely interrupt 10,000 amps, you could put 14 fuses in front of me, but I can still only ever safely interrupt 10,000 amps. The amount of current that I see doesn't matter. It's just defined as how much I can interrupt. So interrupting ratings can't change, right? That's different than short circuit current ratings, right? Because short circuit current ratings, we mentioned, similar to that withstand rating. The idea is these are the devices inside your panel that are not active during a short, right? They are sitting there. They are trying to withstand the amount of energy they are seeing while they wait for an upstream overcurrent protective device to open and protect them, right? And these devices, that short circuit current rating can change depending on what's in front of it. So if you have a current limiting fuse versus a non-current limiting breaker or no overcurrent protective device at all, please don't do that. But it can withstand a different amount of energy depending on what that upstream device is, how fast it opens, whether it's current limiting. That's your short circuit current ratings can change because they are dependent on another device for what they are. So there are, if you go to the next slide, 4 main types of short circuit current ratings that something could have. The first is going to be a standard fault rating. So this is literally it's like the default rating, the minimum rating, and this is just if you're going to have a UL listed product, it must meet at sort of its basic level a certain amount. Now, these standard fault levels are typically pretty low. So, it's when you think of a terminal block only being 10 kA. Well, that's its standard fault. There might be another way to get it higher, but by itself, sort of standalone, it's going to be that low rating of 10 kA. Anything that goes inside an electrical panel, more or less, there's a couple pieces of equipment, mostly like line reactors and transformers, that don't have short circuit current ratings, but everything else pretty much has one. That includes, the receptacle on the outside of your panel, GFCI or not, contactors, power distribution blocks, non-fusible switches, all of those have different, all of these have a short circuit current rating if they're in the path to a load. And that standard fault level is pretty low for a lot of them. So you want to be aware of what that is. And then more importantly, if you're trying to get higher short circuit current rating for your panel, you want to investigate some of these other types of ratings to get them higher. So the next type is going to be a high fault rating. A high fault rating is kind of like a generic combination rating. So in that it's not necessarily part number specific, right? This might be a rating where it says, oh, if say you have a contactor and that contactor is normally 5 kA, but if you put a 30 amp class J fuse in front of it, now it's 100 kA. It didn't call out specifically Busman LPJ-30SP, right? It just said any 30 amp class J fuse. That makes it sort of the high fault rating, that generic optional higher rating. It's actually been tested and listed with UL that these two things together will achieve this higher rating. So that's your high fault rating. The next is group motor, and group motor rating is actually very, very similar to high fault rating, except it's applied in a group motor application. So group motor, if you don't know what that is when you have a one overcurrent protective device that feeds multiple controllers that each feed a motor load. So sort of the standard way to design a panel is you'll have an overcurrent protective device for every single motor controller, which goes to every load. But you can do group motor. There are reasons to do it and not that I won't necessarily go into, but it is a perfectly legal way, an acceptable way to design your panel in UL 508A, provided you follow all of the rules. But when you do it, there's a separate short circuit current rating when you do that. And that's because that upstream overcurrent protective device, right? If you have a fuse feeding 4 contactors that each go to a motor, that's obviously going to be a higher rated fuse than if it were fused to one contactor, to one motor. So as a result, it might be a different rating because that fuse got a little bit larger, not quite as current limiting, not quite as protective. So just really important that you have a different rating for it. And then finally, there's a combination motor controller rating. A combination motor controller is a specific combination of components. So this one is part number specific. So high fault rating was kind of generic. Combination motor controller rating is the opposite. It is absolutely part number specific. It is only in the branch, and it only feeds a motor load. So a single motor load for a combination motor controller rating. But what you get with this is then what you get here is you get a specific combination of components. So it might be like this specific line side adapter with this specific manual motor protector with this specific contactor. All 3 of these together have a rating of X, right? So you don't have to list the 3 of them separately anymore. You say this combination of the 3 of them have this rating, and it's usually a pretty good rating. So it's not a bad rating to have. So those are the 4 main types of component short circuit current ratings that you might have for an electrical component. If you're trying to achieve a high SCCR, you're probably not going to want that standard fault rating. You're going to want one of the other ones that you can get. So with that, generally speaking, right, my steps to determine the overall panel short circuit current rating per UL 508A supplement SB, there's 4 steps. The first is to determine the SCCR for each branch circuit. Step 2 is determine the SCCR for each feeder component. Step 3, identify all of my interrupting ratings within the panel. And then step 4, pick the lowest value from steps 1 through 3, and that is your panel short circuit current rating. So you can see how, right, this is absolutely dependent on those ratings of the devices inside. You go forward just 1 step here. You'll see step 1 can get a little bit complicated. There is a part A and B to it, right? So part A is just to identify the SCCRs of each of your branch component devices, right? That's just a matter of usually looking it up, right? So we would see, what is the rating of this breaker? What is the rating of this contactor? Figuring out what it is and applying that. Part B is it's an interesting part of UL 508A because a lot of people don't know it and don't use it at all. And a lot of people use it incorrectly. So it's just the thing that's in there, and it's like it's saying that you can actually raise the component short circuit current ratings if you have a current limiting device in your feeder. So that could be a current limiting breaker, it could be a current limiting fuse. That device in your feeder, you can raise it. What this does not say, very importantly, is you have a main fuse in your panel, you have a 200 Ka rated panel. That is not what this says. It's a lot more complicated than that. You actually have to verify specific let-throughs of that device. You have to compare it to the devices below. And probably the most important thing is that you can only use this to raise component short circuit current ratings. You cannot use it to raise interrupting ratings. So if you have a very current limiting fuse in the main, but you have a 10 Ka breaker in your branch, you can't use that fuse to raise the interrupting rating of that breaker, even if that fuse let through is less than 10 Ka. So it's part of how it's very, very commonly misapplied. I'm just trying to do UL 508 here at a higher level so we can cover a lot of ground. I do a lot of UL 508A presentations in and of itself, and those are, an hour and a half to 2 hours all by themselves. So if that's something you're interested in, let me know, and we can get into some of the nitty-gritty details of it. But we want to be very, very careful when we apply that. And I've got some of the rules, I think, on the next slide here of applying that. So a current limiting or breaker or fuse cannot be used to raise interrupting rating. That's the first thing I said right now. So this is, just always like to emphasize, a lot of people read that and say, oh, that means if I put a current limiting fuse as my main, I got a really high rated panel. It's not necessarily true, right? You can't use it to raise interrupting rating. So you have to have high interrupting rating over current protective devices all throughout your panel, before you can do that. You also can't use it to raise the SCCR of a combination motor controller. So, right, when I said it was that specific part number of combination, so this plus this plus this, and it has a rating of this, that's what it is. And again, it doesn't matter if you put a current limiting fuse in front of it. You cannot use that. But you cannot use the logic of putting a current limiting fuse in front of it to raise the SCCR any higher. And this is only a way to increase short circuit current rating of a device in the branch. So it's important that this is not using a device in the feeder. And really, the easiest way to think of feeder is like your main, right? It's of your panel. So it's not something in the feeder helping something in the feeder. So it's not, for example, saying that I have a current limiting fuse and it's helping my power distribution block. That's not how we get to use this. And it's not a device in the branch. It's not like I have a fuse in my branch helping the rating of something else in my branch. This is only works for a current limiting fuse in the feeder, increasing short circuit current rating in the branch. So this is, again, I have a love-hate relationship with this specific step in determining short circuit current rating, because it can be very, very useful in certain circumstances, but it's also these rules are often broken and they should not be. It's really, really important that we don't break these rules when we're determining the short circuit current rating of my panel. So, it's one of those exercise with caution. Make sure you are following all the rules when you're doing this. And one other thing to note about when I'm using the current limiting devices, if you go ahead to the next slide, is when we're using current limiting fuses within a UL 508A panel, or really it's within any panel where we're determining the short circuit current rating using UL 508A, we don't get to use the current limiting characteristics of the specific fuse that we're using. So I don't say, oh, well, I'm using a wonderful Bussmann LPJ-100. I'll go to the current limiting chart for that and determine what its let-through values are. Not how it works with UL 508A. UL 508A makes you use the ratings that are in table SB 4.2. And what these ratings are is we call these the umbrella limits for these fuses. And these are the maximum let through that any fuse can let through during a fault by UL standards, right? So if it's going to be a class J fuse, by definition, a 100 amp version of this when it sees 50,000 amps cannot let through more than 12,000 amps. Now, the actual fuse that you're using might be lower than that, and it would be great if we could use that value, but we don't. We can only use the values that are in this specific table as a result. And I mean, the logic for why they do that is because you might design a panel and you might install a specific manufacturer's fuse, and the first time that opens and someone goes to replace it, they're not necessarily going to replace it with the exact same fuse. So therefore, you have to design it for any fuse of that class as opposed to the specific one that you are using. So it's in a way it's nice in that when you're designing your panel, you don't have to go look up every specific fuse. You just get to refer to one table, but this table might not give you as good of values as if you were able to use the specific fuse, because this is sort of the maximum threshold limits for those fuses instead. So just an important thing to note about what we're using. And we use peak let through here. So it's not the RMS let through of a fuse, it's the peak let through. It's a higher value. That's what you have to use according to UL 508A.
So Robert's saying about cannot use current limiting fuse to raise the SCCR of a piece of equipment or component. So, and what I think he's referring to is the whole up, over, and down method, right? Which, again, to your point, 508A is using the up, over, and that's the
Yes.
peak. Up, over, and down would be the RMS. But in historically, we've said, if your equipment doesn't have the right SCCR rating, just put a fuse in front of it, go up, over, and down. And I guess that would be fine if you had things like busway or non-dynamic devices. But the most if you have like circuit breakers or things like that in there, then you really can't use the up, over, and down. You're doing this analysis method basically, and if there's a breaker in there, then that breaker is going to have to be listed with a fuse upstream to say this is what you need.
It's just one of those questions where there's not the answer is a paragraph, right? I can't say yes, I can't say no. The answer is it depends on a lot of things. Basically. So you have to use, it's true, you have to use peak let through. You can't use it to raise interrupting rating, right? So you can use it to raise SCCR, but you can't use it to raise interrupting rating. And the SCCR of a piece of equipment can never be higher than the lowest interrupting rating in the power circuit, even if you have an upstream fuse that has a peak let through lower. So it doesn't matter. So it depends. So sometimes you run into I call it like a sweet spot scenario where, say, your piece of equipment is rated 5 kA, and you have a breaker inside of it that's 10 kA, and your available fault current 8 kA.
Yeah.
Right? That is an application where you might be able to install a current limiting fuse that can reduce the available fault current lower than the 5 kA that the equipment's rated to. And because the interrupting rating of the breaker inside is already 10, you can raise it to above the 8.
That's a good point.
That's a rare situation.
but that's a good point. And I think another good observation there is that just because you have a circuit breaker in there rated for 10K does not mean the short circuit current rating of that equipment is 10K.
Correct.
Yeah. Good point.
Correct. So I know that question comes every single time, and I'm always like, I wish I had a more concise answer for you, but unfortunately the answer is very complicated, and that there are so many factors that go into whether or not you can or cannot, or whether your AHJ will accept it too. Half the time that's the determining factor too, and some of them just say no.
That's true.
So,
and then you may have to get a field evaluation from a nationally recognized testing laboratory that looks at these things.
Yep. So, all right, I actually have an example here for us that we can go through for calculating panel SCCR. We're not using, we don't have a current limiting main here, so we're not using that other step to help us through. We can look at each of these pieces of equipment here, and I think if you click, now we can see, kind of pay attention to where these were marked because it does take away their labels. But we're going to start because UL 508A tells me to start with determining my branch short circuit current ratings, right? So to determine my branch short circuit current ratings, I have to look at each of those. And yeah, my first one is is this branch CD, which is that fuse and fuse holder and that 10 horsepower drive. So we've got 15 amp class DC fuses, interrupting rating 200 Ka, and SCCR of the holder also 200. So we've put 200 Ka right on there. Perfect. D, we have a 10 horsepower drive. Its default short circuit current rating is 5 Ka, but has a high fault rating, 10 Ka, if I'm using 15 amp class DC fuses in front of it. I am using 15 amp class DC fuses in front of it. Therefore, its short circuit current rating is 100 Ka. Great. That means my short circuit current rating of that branch is going to be the lowest value of the short circuit current rating or interrupting rating in there. So my branch short circuit current rating here is going to be 100 Ka. And then I'm going to go ahead and I'm going to look at branch. This would be EF, my breaker plus contactor. I have a 15 amp breaker with an interrupting rating of 22 Ka. So we can just go ahead and apply that. And then F is a 20 amp contactor. It would have a default rating of 5 Ka or an SCCR of 22 Ka with a 30 amp or less breaker. I'm using a 15 amp breaker that is 30 amps or less, so I have a 22 Ka short circuit current rating there. My short circuit current rating for my whole branch is the lowest value between 22 and 22, so it's going to be 22. And that's step one, right? That's step one of determining my panel short circuit current rating. In reality, the hardest part of all of this is actually looking up those ratings sometimes, finding the documentation and figuring out what they are. Sometimes the most time-consuming part of this whole process. Step two is to determine the short circuit current rating for any device in my feeder. The only device here in my feeder that's going to have a short circuit current rating is this power distribution block B. So it has a default rating of 10 Ka or it's 14 Ka with a 125 amp breaker. Now I'm going to look and I'm going to see it's being fed from a 100 amp breaker. Well, so now am I at the default or do I get to use the high one? We get to use the high fault rating, and that's because when I look up short circuit current rating of components, that is a maximum amp rating of an upstream device. I'm always allowed to use a smaller device in front of it. A smaller device is going to, if anything, open faster and protect you better. So it's considered a better protective device, and you can use that instead. So B, even though it says 14 K with 125 amp breaker, I'm using a 100 amp breaker. That's okay. Smaller is okay. If I were using a 150 amp breaker, no go, I'd be back down to 10. And then last but not least, I have to identify all of the interrupting ratings in my panel. So anything in my power circuit that has an interrupting rating, I want to make sure those are labeled. My branches, they're already taken care of. Obviously, right, I want to look at this main breaker. This main breaker, interrupting rating of 35. So I put that on there. And then what I have to remember. So this is a somewhat commonly forgotten thing inside my panel is that the primary protection for my control circuit. So whether I'm going to a transformer or a power supply, right? It could be either a 2-pole or a 3-pole device, depending on that. That counts towards my short circuit current rating. So even though I get to ignore everything in the control circuit, I have to include the primary protection before I get there. So in this case, that is G, this little 6 amp 2-pole miniature circuit breaker with an interrupting rating of 10 Ka. I want to make sure I include that. And then I get to do step 4. Right? Step 4 is pick the lowest values from step 1 through 3, right? So I've got 35, 14, 10, 22, 100, panel SCCR, lowest value there. Last time I checked, 10 Ka is the lowest value there. So that is, very generally speaking, how I'm going to determine panel short circuit current rating.
So you went through
right?
every component, worked your way up, and then you just picked the lowest SCCR. And now, if I wanted to raise the SCCR of this panel, are you going to cover that? I mean, You would,
I-
if I could address that breaker that's 10K, then I could at least pick it up to 22K, right?
Oh, you're at 14 because of the power distribution block.
Oh, yeah. That's right.
Yeah.
I'd have to address I can see why this can be kind of fun trying to figure
Mhm.
out how to get it up to the right SCCR number that you need because like you say, I fixed the 10, but then I have a problem over there at the 14. Then I
Yeah.
got to fix that. And it might be that I have to either get a new power distribution block that's rated with that breaker, or I might have to put a fuse upstream of it. And then I can say, okay, now I've increased that one.
Yep. So it's a matter of you fixed your weakest link, and now you then you go to the next weakest until your weakest link is high enough that it's okay. So, and there's, yeah, I mean, I'm not going to go through tonight all, because that's like I have like
Right.
an hour of going through each and every one of these, and we don't have time for that. But yeah, it's you fix one thing, and then is it good enough? And then if it's not, then you fix that, and then you fix that, and et cetera, et cetera, et cetera. So um, that is how we determine the short circuit current rating
Perfect.
for an industrial control panel, very generally speaking.
Love it. Love it. Love it. Yeah. So that's that's an interesting process to say the least.
Yeah. So if I want to achieve high assembly SCCR, there's really three main things you need to do, right? You need to have high interrupting ratings. You went through that process. There is no way for your short circuit current rating to be higher than your lowest interrupting rating. So you need high interrupting ratings, or at least an interrupt at the at least your available fault current for that piece of equipment, right? So high interrupting ratings of your overcurrent protected devices. You want to have high short circuit current ratings too, right? You want those combinations. Use a high fault, use a combination rating, something that exists where you get that high fault rating. Low short circuit current rating equipment usually comes from people who don't take advantage of they wind up with that standard fault rating, that low rating, because they just that that component probably has a high fault rating if you use something specific in front of it and you just didn't use that. You used something else which might cost the exact same amount of money,
Right.
but you got to use this one instead of this one, and now all of a sudden you have a high fault rating, and that's just of what it's been tested with to do that. So you want to use those combination or those high fault ratings to increase your short circuit current rating, and then maybe use a current limiting feeder to help you. But again, that is very commonly misapplied, so don't apply that piece of it
Mm-hmm.
unless you sit through a whole training with me on when I tell you what you can and can't do with that one. So you can increase lower with current limiting, but you got to follow a bunch of rules before you can do that.
Love it.
So now, oh, one more thing, Oscar 3.0. So this is actually a really, really cool tool that Bussmann has come out with. So Oscar has been around for a while, but Oscar 3.0 is brand new this year. I think it's maybe a month old since it's launched, maybe not even. So what Oscar 3.0 is it is an SCCR compliance tool. So what you're going to do is you're going to enter your electrical component, your electrical panel components. You actually get to drag and drop. It's so much more user friendly than Oscar 2.1 because you actually get to drag and drop these components, and you get to define them. So you get to say, I'm using an Eaton contactor, or I'm using a square D breaker. You actually get to specify the exact one that you put in there. And then it'll provide a one-line diagram and detailed documentation and calculate the short circuit current rating. So it'll do all of that for you. It's a quick, accurate means to use UL 508A supplement SB to determine your SCCR. It's very cool.
So if I had this, and let's say that I was an OEM and I made industrial control panels, and I had my inventory of parts, would I be able to put my inventory in like a library so that I'm using what I have in stock?
Yeah, you actually can do that with 3.0 now. There is a library of parts. So I should
Yep.
say there already is a library of parts. In 2.1, you used to be able to create a custom part, but if you ever used that part more than one, you would have to create it new every time, which was annoying.
Yeah.
now this builds a personal library. So it doesn't necessarily add it for everybody, right?
Right.
So because you add it doesn't mean I get to use it, but if you've added it, you have a personal library that you can pull from. This is, I think that's probably like the that, and it's a lot more just user friendly as and how you build up your circuit now. But it's great. It's a lot better.
Yeah, it takes. I mean, I know that I've talked to OEMs that use this tool,
Mm.
and this is this something you and I know they said they love it because it takes the mystery out of it. They just put things together. It automatically determines they can replace parts and pieces. Now,
Mhm.
is this a it's been a while. It's been a while since for me and Oscar. So my questions are legit here.
Okay.
Is this a software application? Is it a web-based system?
A web-based system,
Okay.
so you can find it online and you get a login. So because you get a login, it'll actually save your work, right? So
Okay.
a lot of the Busman free tools, the fault current calculator, the fuse finder, they're free, but you put something in once and then it disappears. You leave the page and you come back and it's not there anymore. Oscar, you have a login and you can actually save a bunch of your work. So that's great when you're doing panel design. You want to be able to come back and have a record of it. So yeah, you actually have to create a username, password. There is you can start with a free 30-day trial. And then if you're using it and you like it, you can buy it, but the real trick is to call someone from Busman and they'll just give you a free rewards code to get a 1-year subscription.
You mean like Christy?
I mean that won't work, but yes, something you yeah. But yes,
Okay.
you call me and you say, I've been using this, I love this, I want a 1-year version, and I say, here's a code, and you have a 1-year subscription now, and you don't actually, it's not, you don't really pay for it.
Oh,
Um,
yep.
you get a code, 30-day warranty, your 30-day.
Love it.
So very cool software. Very excited about 3.0. It's so much better than 2.1. I'm allowed to diss 2.1 now that we have a better version.
Well, it's got to be better than 2.1 because it's
Yeah,
3.0. It's point
exactly.
0.9 better.
Yeah, yeah, for sure. All right, so now we'll talk about determining the available fault current, right? So SCCR is important, but if we take anything away from the 2017 and 2020 NECs, SCCR doesn't mean anything unless we also know what the available fault current is. So how do we determine the available fault current? There are 3 main ways in a second here. So to determine the available fault current, there's a couple. The easiest thing to do, right? Well, maybe depends on your utility, is to call up your utility and ask them what is the available fault current at this location, right? And they should be able to tell you what it is. They should know the available fault current anywhere that they're uh, when I talked to a lot of electricians and inspectors and such, and they may disagree that this is the easiest method, because getting a hold of the right person at the utility company and getting them to call you back, not always the simplest, but it's a good, you don't have to do any sort of calculation. It of course only gives you the value at the entrance. Right, it gives you the value at the specific point of the utility.
Right.
It doesn't tell you anything else about the rest of your system, but it at least gives you a good starting point, right? The next way is to do a simple point-to-point calculation based on what is installed. So this is where the Busman FC Squared app comes into play. So this is a really, really cool app. You can use it as an online tool, but you can find it in like the Google Play Store, the Apple App Store. Download it and just plug in a little bit of information about your system, single phase or 3-phase, information about the transformer. If you know the available fault current, if you got that from the utility, you can start with that value and then just say, and then from there I have this much conductor run. What's the available fault current at the end of the conductor? It'll spit that out for you. If you can't get that information from the utility, but you have information about the transformer
Hmm.
that's installed coming in, you can put in basically the nameplate info from that transformer, and it'll tell you an available fault current. And then again, you can continue to build your system. So you can do a conductor run, you can do a bus run, etc. from all there. So a free app, really quick, simple, very user friendly for
Hmm.
how to build up your system. And from there, it can also it'll email you the labels. So the labels that you might want to put on your equipment, NEC compliant, all the information that you need on there for your labels. And then you can also print out the documentation piece. So it'll say you built up your system, and it'll give you a nice little PDF. Here's your system. Here's the fault current calculations. Something that an inspector, I think, would gratefully take as documentation.
Absolutely. And it meets the code, because remember, the code wants to document how the one-line diagram will let the inspector see the conductor that you use, the length that you use, because you have that little one-line diagram. And Joe Bellantoni is a fan. Most people I know, I mean, this is a very heavily used app, and I know what I like to do is just run some scenarios, and I'll play with it, and just because you don't need to model the transformer. You can just say, look, I know what my fault current is at the front end of this conductor, and put a conductor length in, put a conductor size, number of conductors in parallel, run those examples. They're great for classrooms. They're great for just getting that ballpark figure in your head. And again, it's the more detail that you have, the more information you have, the better chance that you'll have of not having to, go to a higher rated piece of equipment, or you'll know that you're going to have an issue. And even in the design phase, you can run some estimates. I love this app. Absolutely.
Yeah, it's the best. Like, everybody watching, download this right now.
Yeah, absolutely. And they can just go to now. They can go. I just went on my phone into the app store, and I searched on Busman. What do you? I mean,
so if you search Busman, first of all, 2 S's, 2 N's in Busman, so spell it right. Then this app and another, the Fuse Finder app, also a great app, will show up. So if you search Busman, 2 things will show up, this being one of them. If you search FC2, it'll also come up. So either of those 2 ways, if you search either of those.
yeah. So you got
sometimes
I
tell people to do FC2 because nobody spells Busman correctly.
Yeah, that's true. So you're saying Richard Curran said he just used it today.
Love that.
So you're saying FC and the number 2.
Yep, it should come up.
Oh, there it is. It's the third one. There is an app called FC2 Video. So, and there's a it's a unicorn. But in any case, there it is. Fault current calculator.
Perfect.
RC blows, Cupcake Island. Awesome.
Yep. And of course, so this is the way that I recommend, for most people are going to use this method. It's certainly the easiest, fastest way to get a very, very good estimate of available fault current throughout your entire system. The best thing that you can do is actually do a detailed short circuit study, right? You're hiring a third party most of the time, I would assume, an engineering. You could hire Eaton, you could hire any of the major manufacturer engineering services, probably do this, or even other engineering services firms. They come inside, they measure and determine exactly how long these lengths are of what, and provide you a very detailed report. A lot of times this is part of an arc flash study. So if you get an arc flash study done in your facility, this is sort of step 1 is to do this, and then step 2 is to do the arc flash study. So it's included in that way. So that's obviously, you're going to get the very most accurate values that you can get. It is the most expensive and takes the most amount of time. So sometimes you really just want that back of the envelope calculation, use FC squared. If you're the owner of the facility, you might think about doing the detailed version. We will determine the available fault current. And now we go to the next slide. I believe
there it is.
We finally get to talk about what we do if we install a piece of equipment that has a short circuit current rating lower than the available fault current. So we're finally at that point. And generally speaking, you got 2 solutions, right? If the short circuit current rating is lower than the available fault current, you can either raise the short circuit current rating or lower the available fault current. That's it. They eventually have to be a certain way. So to lower the available fault current, Your methods are usually just introducing a whole bunch of impedance. So that could be in the form of a transformer. Transformer is actually a pretty fast way as far as a method to do. I never like to suggest this method though, because when you really think about it, right? If you install a transformer, you're introducing all of the losses that come from that transformer into the system for the rest of its life. You've just lost all of that. You've just made a higher power bill for eternity because of it. So I don't really like it as a solution. It'll technically work, it'll pass code, etc. But I don't prefer it as a solution. I'll just put it that way. You can also install something like a line reactor too, right? A line reactor can also drop the available fault current in front of it. Those are just usually more expensive and with longer lead times. So you almost never actually see them being used as your method for that reason. You can increase your conductor length. This only makes sense in a couple situations, right? You have to be pretty close, right? Increasing your conductor length, you're not going to just like add 500 feet extra of copper wire on top of your rooftop when your rooftop HVAC unit doesn't work, right? And you may as well install a transformer at that point if you do that. This makes sense if you're really close. And if you're really, really close and it's the difference of 5 feet of conductor could make it so that you meet this requirement, then you tell your electrical contractor when he wires it up to go like up, over, and around instead of straight to it, right? But again, it's really only works when you're very, very close to meeting that requirement already. And that's basically it when it comes to reducing available fault current. Those are your options, right? The next thing is to increase the short circuit current rating. The best way to do this, in my opinion, is to get a national recognized testing laboratory out there, a third-party service, have them do a field modification of the equipment and relabel it with a new short circuit current rating. That is always the best solution. When it's the best solution, that also means it's probably the one that takes the most amount of time and is the most expensive. So I think it's probably not done as frequently. But, from a true sort of engineering standpoint, if I were to ever recommend a solution, that's the one I would always recommend. It's going to be sort of the best guarantee for your system. And then the last one, this is the one why people call me all of the time, right, is can I install a current limiting fuse? And so it's really important to note that for most pieces of equipment, there's two ways we can do this. But for most pieces of equipment, when we install a current limiting fuse in front of it, we are installing the current limiting fuse in order to increase its short circuit current rating, not to reduce the available fault current. Right? A lot of people say, oh, it's a current limiting fuse. You put that in front of it, it limits the current to this, and that's less than the rating, and it's all okay. That's not actually the logic we get to use for control panels. We have to use the logic of calculating it as if we were using UL 508A and basically saying now we have this current limiting device in front of it. So whenever we use this, it's important we use peak let through, right? Because that's what UL 508A tells us to do. And overcurrent protective device inside that piece of equipment still must be adequate for the available fault current. So those two things you have to do if you're going to try and install a current limiting fuse. And sometimes you can find a good solution using those two, and if you do, it's fine. But a lot of times you wind up having to swap out an overcurrent protective device inside of it anyway, because no matter what, that has to be greater than the available fault current at that piece of equipment. So.
Next slide.
Next slide. I'm going to talk a little bit about series ratings because this is sort of the other way to increase your short circuit current rating. We got a little bit of a facelift to the series ratings section of the NEC is really, again, just one of those, like, they changed the language a little bit to hopefully make things clear. But so series rated, right, this is when you have a higher rated device, a lower rated device, and then the available fault current at the lower rated device is higher than what its rating is, right? And then hopefully you're going to use the higher rated upstream device to increase to make this series rating with the downstream device. And there's a couple of requirements you have to meet in order to do this. The really, really big thing to know is there are engineering solutions to this, and then there are tested series rated combinations. If you are installing a new piece of equipment, you can only use tested combinations. Good news is there's like millions of those, but it must be a tested listed combination, an engineering method, which is what most people think of as up over down, which it isn't even necessarily up over down anymore. um, you can't use that in a new. It's only for existing applications are you allowed to use those. So only use tested combinations for a new one. You go to the next slide. You'll see the requirements for an engineer's series rating, and I basically recommend nobody do one of these.
Oh, really?
um, and a lot of it is like, so it has to be done by a PE, and they have to stamp it. So if you're a PE, you have to be really, really confident that like you're testifying that these are going to work together. And there are so many tested series combinations that use one of those.
Yeah.
Like, why would you go out on this limb? There's a very, very there's a lot of liability out on this limb to be able to use this engineered series rating. So don't yeah, just try to use a tested. If you have to use a series rating, you should be using fully rated systems. But if you have to go to a series rating, yeah, because you just good luck finding a PE who wants to put their stamp on that.
Yeah,
I wouldn't.
and the reason they go, in this, whenever we go down these roads, if you're doing this, you're doing this because you want to spend less money from an interrupting rating, right? Because the higher the interrupting rating, the more expensive the device, right? So we do these things to lower the cost, but whenever you do that, I would say this goes to no matter what it is. You could go down and say, I'm going to buy a tool from I'm going to buy this tool, and it's like, I can go to this place and it's only $12. I go to that place, it's $60. And you got to say to yourself, how often am I going to use that tool, right? Because if you're going to use it for a period of time, you're probably going to want to spend a little bit more money as an investment. And whenever you get into these things like series ratings, you're going to have to cross your T's and dot your I's, because to your point, you make a mistake, a fault happens, you get that unintended rapid disassembly in the field, somebody calls you and says, this happened, and then you go, well, I did this, and they say, well, we talked to the manufacturer, and Christy Rosati was out here, and she showed us that, you made this mistake. Well, why did you go down that road to begin with? Because it's really,
Right.
at the end of the day, I don't believe it's really all that much money.
Yeah.
That's what it comes down to. It just comes down.
Yeah.
But it's
I mean,
easy for you and I to say that because we sell the product, right?
True.
But
It's also like the only time I can like see series ratings where I'm like, okay, fine, is in something where it's existing, right? You are doing a renovation on a piece of on a building that was built 50 years ago, and the available fault current is more now. And now you maybe want to do series rating instead of replacing everything. I kind of get it. So the idea that you would ever do it on purpose for new equipment is there are a lot of requirements. I'm only kind of touching on some of them here, but you've got an additional requirement to count up all your motor contributions. There's a lot that goes into the labeling in the field to make sure this all goes right. And there's just a lot of liability, and it's do you want to be in charge of that liability, or do you want the manufacturer listing on the panel to be in charge of it? I know what I'd pick.
Absolutely, because especially if you're putting a PE stamp on it, there's a legal binding there, and that's a tough road to go on. You better know exactly what you're doing.
Yep.
God bless you if you do.
And PE is professional engineer for the person. It's a yeah.
Oh, that's right. Tamaki, she's from Japan, or he's from Japan. Thank you.
Yeah, and there's just additional labeling requirements. Again, this is something I don't want to necessarily read through, but you have to mark both the upstream equipment and the piece of equipment that is being series rated with these like caution labels. Caution, this is series rated. Whenever you do any sort of maintenance, you got to be super extra careful. So it's just another thing that you have to do when you have series rating. And then if you go to the next thing, I believe it's motor contributions. Yeah. So another thing, and a reason why we typically can't series rate industrial control panels is because there's so many motors involved. When you have motor contributions, so what this is going to say is, if you think of, we'll just think of this as a panel board with a main breaker, right? And that main breaker, 22 kA. And all of the branch breakers are 10 kA. And we want to say this has a series rating of 22 kA, which maybe it does, but we cannot apply it in a situation if those branch breakers, the other ones, right? Not necessarily the one that's series rated, but all of the rest of them,
Hmm?
if they go to motors and the motor FLA adds up to more than 1% of the interrupting rating of that branch breaker that we are series rating, then you can't apply it. So in this example, the sort of, we've got 10 kA on there. So 1% of 10,000 is 100. If the full load amps of all of my branch devices wind up being more than 100 amps, I cannot series rate this. So this is why series ratings you typically only see on things like lighting panel boards where there are no motors involved, because this is a very, very limiting part.
This is something that, in my opinion, there are so many people not doing this, because I've done training classes just like you do. And I was down south, and I had a gentleman come up to me after my class, and he looked and he says, "I think I have a problem." And what I told him, like you said, I said, most of the times we're using this on lighting panel boards. He goes, "No," he says, "you don't understand." He says, "I make um, car washing." He's, "I have the design for car washers." And I was like, well, that this tells you my ignorance, right? I said, "There's not that many motors in a car wash." He's like, "It's all motors." I was like, "Oh my gosh, that's a good point." But, and big motors too. So
Mhm.
he had some major issues going on that he had to go back and look at his designs, because that's a chain.
Yeah.
It's commonly missed.
Yes, absolutely. So that's, and another really big thing is that you lose selective coordination when you series rate. So the whole idea with a series rating is that the upstream overcurrent protection device protects the downstream device.
Hmm.
So during a short circuit, that upstream device opens. That is inherently not selectively coordinated. And for
Right.
those who don't know what selective coordination means that you don't have more than one overcurrent protected device open during an overcurrent, right? The idea being you get blackout, you get unnecessary loss of power to other circuits whenever that occurs.
Yep.
So inherently lack of selective coordination. So you cannot use series ratings in any circuits that require selective coordination, which, Tom could probably list all those off the top of his head, but
Oh, yeah.
emergency systems, legally required standby, critical operations power systems, critical operations data systems, multiple fire pumps, and multiple elevators. So like those are just period, end of story. No series ratings in those, because you inherently don't have selective coordination. So, and then of course, when you go to future expansion, right, there's it can be a problem with that. If you don't properly label all of your equipment, you might say, oh, that was a 10K rated panel board, not realizing it was series rated to something higher. And then you think there's a lower fault current there than there really is. So that's a really big thing about it. Um, your short circuit current rating could now exceed the combination rating, right? So it's also the fault currents only ever get higher
Yeah.
whenever right? The power just gets more dense, and when power gets more dense, the fault currents go up. So when you add capacity, etc. You could have new equipment installed that doesn't have a series rating with it. It could just lots of um, it makes it a lot messier in the future too. So yeah, you just don't do series ratings unless you really, really have to. But sometimes that isn't in fact what you are doing when you have insufficient fault current, is you are going to find a series rating, and if you do, use a tested combination. And what's interesting is when you look it up, it's typically going to be a series rating with the whole panel board. So there are series ratings of like fuse plus breaker or breaker plus breaker, but a lot of times it's actually, hey, I have a Eaton Powerline 3 or 3A or however, I don't know, they do weird things with the letters and numbers. I don't remember what they are anymore. And then so it's a fuse plus an Eaton Powerline 3, 4, whatever.
Right.
Separate, and you get that combination for the whole thing. But again, lighting panel boards only, please. if you do it at all. Always recommend a fully rated system.
Loving it.
Yep. And with that, I think we're finally right at the end here. So in conclusion, available fault current. We got to know what it is, right? We have to determine what it is. We have to document it. We have to actually field mark a lot of pieces of equipment, but at a minimum, document it. The SCCR, right, which is the rating for my whole assembly of equipment, that has to be greater than or equal to the available fault current. You can use the FC Squared app to help you determine what that available fault current is. It's a great thing to download and use. Current limiting fuses, you can use it to increase SCCR only if the interrupting rating of the downstream device is adequate. You could use a series rating if it's not, but make sure you carefully follow all of the NEC requirements when it comes to series ratings. And we always, always, always recommend a fully rated system over a series rated system. So I think I got one more slide of just some resources for you. So Oscar 3.0, that's up there. That was that tool that helps you calculate short circuit current rating in an industrial control panel. We have a code changes booklet for both 2020 NEC and 2017 NEC. These are fantastic. If you've never used a Busman code changes booklet before, they're one of the best technical documents you'll ever read. It goes through old code, new code, some of the product changes that you have to make as a result. Really, really great informational documents, and those are all available on Busman's website. The fault current calculator, again, we mentioned that in your app store or Google Play Store. And then the SPD Electrical Protection Handbook, if you've never heard of that, another amazing, I have mine. I always keep mine right next to me. There's a million tabs in it. There's thousands of coffee stains and rips and tears because I use it so much. It's the Electrical Protection Handbook, and it has so much good information. It has some just current limiting charts for fuses in there. It has voltage drop calculations, the long form way to do fault current calculations. It has all of those tables and charts that you need for UL 508A. It tells you how to size a fuse for a transformer, medium voltage, low voltage, and everything in between. So it's really, really, really handy handbook there that, it's also available online. Can't recommend it enough.
David Rodriguez wants to know, how can he get a hard copy of these books?
You got to know a guy or a gal. No,
Yeah.
you can, if you have my contact info, and I can send you, I don't know if you're in the United States. If you're in the United States, I know I can send you one. If you're outside, I can try. I've never tried before.
Yeah, David, send us an email with your contact information. I'm gonna put just for everybody's things, I'm gonna put mine in here just in case. Thomas A. Dimitrovich at Eaton.com, and then it's CHRISTY Christy.
Yep.
Oh,
MCEL.
oh, okay. So no middle initial.
No middle initial. Yeah,
MCH.
No H.
MC
EL
EL.
HINNY at Eaton.com.
Columbia. Can we send them to Columbia?
I honestly have no idea, but I can try and
We
see
can
what
try,
happens.
Felix. I think I have your contact information already. So, but David, I'm not sure if I have yours. which reminds me too, on my website, if people sign up on register over there, that give me that information, and at least I'll know where everybody's at, and we can figure out the best effective way to get some resources down there. So, and you know what, Christy, we have if I'm not mistaken, we have offices down there, right? Don't we, in near Columbia? I'm not
I mean, I
sure.
imagine.
Yeah,
I
I'll try to find out, because they might have something locally down there. So, but
yeah. I just don't. I've never tried, so I
yeah,
don't know
me neither.
what's gonna happen.
Well, I did send Felix a mug once, so
Oh,
yes, perfect. Okay, so Christy, um, just me and you now. I mean, we did we covered
yeah,
a lot of land.
we
And
did.
David Rodriguez says he's worked with Eaton, Columbia, so we could talk to our Columbia connection within Eaton and see if they have a good, effective way. Because the challenge with some of this literature is it's really expensive to ship down there, and it's heavy
Mhm.
and it's bulky.
Yeah, it
So
is. I mean, it's
yeah, and so
the book.
we'll have to see what we can do to do the connection, because I think that's important. I personally, I like the physical books, so I have my library behind me. Well, that's it's a different library. Yeah, my library behind that green sheet, which doesn't look anything like the library that's behind me. But yeah, so that's an important part of. We'll definitely try to connect with people on that, in that regard. I think we've covered a lot of the questions. And if it all fails, reach out to your local power systems engineer. That's true. Mohammed, Eaton has a lot of power systems engineers across the country, our engineering services division. So when you get into these jams, or you want to try to figure out how to engineer a solution, especially if it's after the fact, connect with the Eaton sales office, Christy, and others. If you're watching this and you're not, like, you might be in Japan, or you might be in Colombia, there's a local offices, and there's local services, engineering services, that can help engineer solutions and come up with options for you. So make sure you connect with those individuals. And what I got to do is, I know there's a if you go to eaton.com, Eaton location, there's a locator within our website, and then you basically put like a zip code or whatever, and it'll show you the local. Yeah, there it is here. So for example, if we do this, so this is that's USA. So or use my current location. So I know there's got to be other locations for Eaton global locations, because we are global, worldwide locations for Eaton.
That's the word.
Yeah, so you should be able to, and we'll try to help with that, that recipe. So I think we did pretty good. Richard Curran, and he had a question up above. I can't remember. He asked about the short circuit current rating of a main lug only panel. All panel boards will have a short circuit current rating. And remember, you have to always protect a panel board with an overcurrent protective device. So, but it will have a short circuit current rating, and they'll give you the recipe. I'm just looking. Selective coordination series rating involved also. Is selective coordination and series rating involved also? And I think you touched on that, Christy. If you are series rating, you're not selectively coordinating. It's a fully rated system.
Yep.
And DeCelera RA RA, typically the ICR. So it's the lowest device, and that is true. Then you covered that very well, I thought. Robert wants a shotgun rating. I don't know about that. Yeah, that's West Virginia talk there, I think.
That is my territory.
Yeah, there you go. That's right. And there's Vinny. Does terminal blocks affect it? So I think I'm just looking through some of those earlier questions. Now I see, so I've got some new found Eaton region. Andina, whatever that is, got it to go. Got to go. Thank you, Moises Fuentes. Thank you very much. And Joe Bellantoni, thank you very much for dialing in. David Rodriguez, Chris Fink, everybody out there who dialed in, thank you. And Chris brought up, he IM'd me on the side about knowing about these. So remember, Tuesdays and Thursdays I go live, and I did put together a calendar on my website. If you so if you go to calendar of events, I've got all of you. If you go view more, I've got all of the events out there, and I'm planning for May, Electrical Safety Month already. So we're putting that calendar together. I've already confirmed on the 29th, we're going to have Mike King talking about engineering services. And I'm not sure what the topic, but we're going to be talking something, and I think it's going to be in maintenance world, because he's in our services division. He does a lot of educational stuff. So I think we're probably going to focus on maybe some either maintenance or primary current injection testing of breakers and things like that. And I'm filling out Electrical Safety Month, which is May. So please go out to that website, and that'll at least give you the calendar. James Smith, thanks for joining in, buddy. So hopefully that will help everybody. And then if you sign up for that, Christy, what I'm trying to do is let everybody know what we're working on and like this event here. So historically, so I'm on a learning curve. So what I'm doing now is, it started off like I just press a button over here that says live, and boom, I'm live. And then I said,
Sure.
you know what? People are like, well, I didn't know you were going live. And I wish so I said, well, what I'll do is I'll go live in the morning and say, here's what we're talking about this afternoon. And that's my marketing, and then I heard somebody say, hey, I need a calendar. So now I'm like, okay, well, I got to figure out how to make a calendar. And I was talking to David Smith, and David goes, well, why don't you just create or go to Google Calendars? So I did. And then Google Calendars says, well, you need there's plugins for websites. And I'm like, well, I need a website. And then David goes, well, why don't you just go get thomasdimitrovich.com? I'm like, there's a concept. So that's what I did.
I hope that was available.
Yeah, it was available. David Smith is not available. I don't know. Christy McElhinny might be available too, and it's like $2.50, so it's cheap. All right. So Restream says I've got 100 messages today with Restream chat. Excellent. So we broke 100. That's the first time I've ever seen that. So Christy, this was a very good, engaging dialogue. So thank you to everybody out there. Richard Curran and David Rodriguez. Felipe Andrea es parte de Eaton, Colombia, de parte de Fuentes. Excellent. So David Rodriguez, we're making connections across the globe.
Love it.
We're international.
Yeah.
I
always claim that I can make short circuit current ratings as interesting as you can make short circuit current ratings.
And we broke 100 messages today. So that's awesome. All right. Well, Christy, thank you very much. I really appreciate you taking your time. This is 5 to 7. This is your time, and I appreciate you donating that to the cause. So thank you.
My cats are staring at me because it's about dinner time.
So
I'm surprised they have not interrupted yet. They've been for the past 15 minutes. They know it's almost dinner time, so I got to go feed them, and then myself.
Beautiful. Me too. So thank you, and thanks for everybody out there. So Mohammed, everybody, thank you very much. Remember, thanks for what you do for the electrical industry. Thanks for what you guys do and gals do for electrical safety. Stay safe and please stay healthy. I'm going to sign us off here, Christy. I'm going to hit this button that says end. And any last words?
No, it was a pleasure being here.
Thank you. Okay, everybody. See you next Tuesday, 5 o'clock. Be there.